Hello everybody, welcome to another video lesson. Today we're taking a look at distributions of data. At the end of this video, we will be able to use the shapes of distributions to select the appropriate statistics and compare our data. So let's hop into our concepts. Data distributions, what are those? They're just representations of the frequency of our possible data values. So it's just telling you how many times a data value is coming up within a data set. Now we have three types of distributions. We've got symmetric distribution here in the middle. That is where our mean and median are approximately equal, right here in the middle. And it has this nice bell curve right here. That is a sign of symmetric distributions. Now we have negatively skewed and positively skewed distributions as well. Now remember, it's kind of hard to remember which one is which. You're always thinking about the tail end here. Where is the tail? Is the tail off to the left where the negative values on a number line are? Well, then that is negatively skewed. And if the tail is off to the right where the positive values in the number line are, that's going to be positively skewed. Okay. Now, when we look at a symmetric distribution, we can use the mean and standard deviation in order to accurately reflect the center and spread of the data. So you're going to be asked a lot to describe the center and spread of the data. And if you have symmetric distribution, you can use the mean and standard deviation to do that. Now, if you have skewed data, that often means that we have outliers present in our data. Now, if it is skewed, we can't use mean and standard deviation to accurately reflect our center and spread. Instead, we want to use the 5-number summary. And if you don't, it's just our smallest data value, first and third quartiles, our median, and our largest data value. So these 5 points here make up the 5-number summary if you are going to reflect or describe the center and spread of skewed distributions. Now we also have, so this is looking at distributions in the form of histograms. We can also look at them in the form of box and whisker plots. Okay, so a very similar representation. However, this is more a visual representation of that 5-number summary. So here I've got our minimum, that's what's here on the left, and then we've got the whisker part of the box and whisker plots. And then the box is created by the lower and upper quartiles and the median. The median is the line that goes through the box. Now the lower to upper quartile, that range is called my interquartile range, my IQR. Okay, so whatever that range is in between the two, that's my IQR. And then we end here on the right side with our maximum data value. Okay, so let's get into some examples. First one here, we're going to use a histogram. We've got annual rainfall over a 24-year period is shown here. And we're going to create a histogram and describe the shape. And then we need to describe the center and spread of the data using the correct information, the correct values. And we need to justify why we did that. So let's go ahead and get our calculator up. All right, so we have our calculator up now. We're going to go ahead and go to Stat, and that's going to bring up this page here. You hit Enter, and we will arrive at our list. So if you were to scroll over to list 1, that is where you would input each one of these values. So you would put 27.2, and then you just hit enter and it goes down to the next value. Now notice this is L1, so if you ever want to recall L1, you would hit second and then see this L1 down here. That's how you would recall that right there. So we then want to go second stat plot. We're going to go stat plot 1, that is currently turned off, and stat plot 2 is on. So let's go ahead and turn stat plot 2 off. Go back to stat plot, and we're going to turn this on by hitting enter. And we want to select histogram, and we do that by going down to type, and we're going to select this one right here that kind of looks like a histogram. So scroll over, make sure you hit enter, and that one's going to be highlighted right there. And now our X list, again, L1. If this said L2 by chance, you would hit second, L1, and then L1 would be called up. All right, so now you're then going to go ahead and hit graph. Now you might not get anything that shows up, or say you're at a standard window. So let me see, zoom standard. Okay, it's going to look really weird, right? It's not going to look correct. So you're going to have to go to your window, and you're going to have to really think about what's going on with your data and what window might be best. So let's start with an x value of 0, and let's see, we're going to go all the way to maybe 40. And then our scale, let's make that 3 right now. And then our y minimum, we'll want that to be 0 as well. And we'll leave that at 10. And if we hit graph, let's see what we get. Okay, we're starting to get something here, okay? So let's go ahead and increase our minimum x value. Let's go 15. And then instead of 40, let's go maybe 42. We'll keep that at 3. And let's just see what this looks like. Awesome, that is what we want right there. So we can go ahead and take a screenshot of this, and this will be our data distribution that we use. Now notice here, I have 1, 2, 3, 4, 5, 6, 7, 8. So you want to shoot to have 7 or 8 of these frequencies here for your histogram. If you are collecting, or if you are creating a histogram and you only have 2 or 3 of these columns, then you don't have enough. Okay? It's not going to give you the accurate shape. So you're shooting for maybe 6 to 8 of these to have a proper histogram. All right, so bringing over that histogram, here's what this looks like. And you can see that this has a symmetric distribution. So we would say that this distribution is symmetric. So we're going to use our mean and standard deviations for describing the center and spread. Now we can find that pretty easily on our calculators again. If we come over here, back again to stat, click over to calc, and this first option here, 1var stats, click enter on that. Make sure you got the right list. So see how this says list 2. I'm going to hit second L1. That gives me list 1. And I can just hit enter until I get calculate. And I'm going to end up with a screen that looks something like this. Now this first option here, this is my mean. Okay, mean is this first one. And my standard deviation is going to be this option right there. Okay, that is my standard deviation. Okay, so if we're going to describe our center and spread using this, then we would say that the rainfall was, the mean rainfall was 29 inches with a standard deviation of 5.4 inches. Okay, and that would be your answer there. All right, second example, similar, but we're going to do a box and whisker plot with this one. So we have some data here. Cynthia reviewed the number of minutes she spent texting her friends each month for the past 2 years. We're going to create a box and whisker plot now to help us describe the shape of our distribution. So let's jump into our calculator again. Now this time I'm going to go to stat, edit. Now I already put in our values here, but I put them in list 2. So now whenever I create my graphs or create my variable statistics page, I'm going to do that recalling list number 2. So again, here I will go to second stat plot, turning off this first one, and I'm going to go and turn on this second one by hitting enter. Now if I scroll down to type, in order to create a box and whisker plot, I'm going to scroll over to this option right here. You can see it kind of looks like a box and whisker plot. Okay, so make sure you hit enter and that one will be selected. Scroll down, make sure list 2 is selected here, and then you'll go ahead and hit graph. So we can see here again messing around with the window that we're looking at, but we have a box and whisker plot here that is negatively skewed. So I know my data is negatively skewed. And with that, I need to use the 5-number summary. So bringing back my calculator, I can go to stat, over here to calc, the same 1var stats that I'm going to use option. And now I want to make sure I have list 2. So I'm going to hit second, list 2, and go down and select calculate. Now when I do that, again, I've got my mean here, my standard deviation, but I have a little down arrow. So I can actually scroll down a little bit, a few options. Okay, now this last 5 numbers here, that is my 5-number summary. I've got my minimum, my Q1, my median, my Q3, and my max value. All right, so those right there, those last 5 options, that is my 5-number summary. So you can go ahead and just pull those straight from your calculator. Okay, so now that we have all of the data that we need for our 5-number summary, we can go ahead and make our conclusion that the median is 655.5 minutes, and the half of the data are between 616.5 and 670.5 minutes. Okay, that's how we can describe our center and spread using that 5-number summary. All right, now let's get into some comparisons. We have typing speeds of students in my 2 algebra classes shown here. So we've got the 3rd period and the 6th period algebra classes. We're going to create a histogram of each data set and then compare the distributions using the appropriate statistics. So anytime you see that, you should be thinking, well, should I be using mean and standard deviation, or should I be using my 5-number summary? So again, you're going to go ahead and open up your list here. You're going to input all of your data, and then you're going to create histograms of each of these data sets. Okay? And when you do that, you'll get 2 histograms that look something like this. And we can see here the 3rd period has a symmetric distribution, and we have a positively skewed distribution on the 3rd period data set. Okay, so since this is positively skewed, I'm going to go ahead and use the 5-number summary in order to compare these two. So for period 3, I've got a range of 23. For period 6, a range of 25. I've got a median of 33 and a median of 27. And my lower quartile for period 3 is actually 28. So what does that mean? That actually means when I compare this lower quartile here to my median, that period 3 lower quartile is greater than period 6 median, which means that 75% of my period 3 speeds are greater than 50% of my period 6 speeds. So without even completing the 5-number summary, I can conclude that period 3 has better overall typing speeds. All right, last example here. John compared his golf scores for 2 seasons. We're going to create a box and whisker plot of each data set and compare the distributions, again, using the appropriate statistics. So you can go ahead and input these into your list. So you have a sophomore season and a junior season. And then you're going to create histograms. Now with histograms, you can actually overlay them pretty nicely in your calculator. So you can have 2 plots on, and both of them being on histogram. Just make sure one of them is referencing list 1 and the other is referencing list 2. So when you do that, you'll get something like this. So you can see how they just kind of stack on top of each other real nice, and you can compare them right away. Now let's think about the distribution that we have here. Well, these both look like they are symmetric to me. So we have symmetric distributions. So we're going to use our means and standard deviations to compare these. Those are going to be the appropriate statistics for us to compare these. So we can go ahead and find that one var stats page. We're going to do this twice though. Again, we're going to do it for list 2 and then for list 1. So here I've got the sophomore season. That was our list 1. And then our junior season for our list 2. And again, we're looking at this first option here for our mean, and then this option here for our standard deviation. So for sophomore season, my mean was 47.1 and my standard deviation was 4.4. My junior season had a mean of 43 and a standard deviation of 2.6. So from this, we can conclude that John had a lower mean and a lower standard deviation, which means that not only did he improve, because in golf you want to have lower scores, but he was also more consistent because that standard deviation was also lower from his sophomore year to his junior year. All right, guys, that is it for this video. Good luck with your practice.